So, hello, good morning. It's 10 a.m. 10 seconds, so about time to start. Welcome. This is the Nfvrg meeting, just in case you have not noticed. And well, the idea is that we have, as usual, a very tight schedule. So we will try to speed up things as much as we can with the presentations and all the like. As usual, oh no, this should move, but I don't know why it's not. Now is the interesting part. Now here. Okay, this is the policy warning. It's not an O2L because this is not an IETF working group. It's an IETF research group, but we're following essentially the same policy. Just for you to know that whatever you say here, whatever you share here will be under the general IETF IPR policy. This is something that came out from some recent meeting of the AG. Is a explicit request to you all to contribute by reviewing documents. So documents are as good as the number of people, as good as high is the number of people that review them. So please, something that this lending says is a plea in general for you: review the documents, make comments, share comments on the list. Don't be shy about your comments. Complain about whatever you see, because that will translate in a much better results of our work. And for sure, if you plan to prepare a document and you're expecting someone to help you improve your documents, the way of contributing is precisely by reviewing the documents. Just there you have the some of the links on the slides, how to remote participation can be accessed, the mailing list for those of you that is your first time and want to have an idea of what we are doing here when not meeting, and the web and wiki. We asked, as usual, for when announcing the agenda, for note takers and scribes. I am so glad to see that we have 3 people volunteering for that. That will translate again in a much better quality of the minutes. So we have Dirk, Sarah, and Linda. That is somewhere in the. Hey. So thank you so much. And we need someone that could take care of the Jabber. That means that the Jabber is something very simple. You just connect to the Jabber, and if someone makes any comment, you just translate it, bring it to the mic. Okay, thank you, Dave. So you will be noted in the minutes with our appreciation as well. Thank you. Again, this is something that we announced last time in Buenos Aires. Let me say, the idea is that we are not going to use any longer making announcements on the meeting, during the meeting on the events. Please use the list for that, but limit your announcement to research relevant events. Please, no commercial announcement, no industrial event calls or whatever. So the idea is that research call for papers or announcements of research conferences and issues or calls for papers for special issues on publications. And we're not announcing open source releases that can be used for research activities. And if you have any doubt, Rankia and I are here to help decide whether such an announcement should go through the list or not. But please, in case of doubt, ask before, because we would like to avoid precisely to push back about any commercial announcements. Very quick. Probably you have noticed that we have changed, as agreed in Buenos Aires, we have changed the near-term work items. They have been updated, and we have been talking with the IRG chair, because the original ones were included in the charter. The idea is not to have them in the charter. The charter is something that is hoped to remain stable along our lifetime or so. And the idea is to have these near-term work items, to have them as part of the in the wiki. something that we can change as we see fit. So the old version is still on the, well, when I checked a couple of days ago, the old version was still on the, in the charter, but this will disappear anytime soon. So you're warned that the reference description of the work, near-term work items are in the wiki. We had, we appointed two editors for the document and work item on policy-based resource management, but one of them, Norival, had to step back because different assignments in his job position. So we seek it from someone else. And well, Sunjik was originally was willing to participate when we started, and he's now being a new editor together with Robert Sabo. And just the final announcement before we go into the meaty part of the meeting. Meaty part of the meeting sounds well. Yeah, no, it's something like, by chance, but this is something that in the future we will use. I like it, how it sounds. Sorry? So the idea is that is just as an announcement. Probably you have seen it on the agenda, but the important is that what is marked in the agenda as the Nfvrg meeting on Friday, on the Friday morning session, is going to be a joint session from bringing together contributions from Nfvrg, NMRG, that is for NM is for network management, and the SDNRG. The idea is to address precisely management issues for virtualized and software-based networks, and is in the first session in the morning on Friday at 10 in Potsdam 1. You have the agenda there. Well, we will start moving to the agenda. First, this is more or less the schedule. I have been extremely efficient and consumed less than the 10 minutes originally, unless there is any comment or question on the quick review we have made. Good. So the idea is that we go on the well, we start with updates on a couple of updates on the already adopted drafts. The first one is you, Robert. So.
Thank you, Diego.
So, well, as usual, we will use my laptop for presentations, and the idea is that you warn me about when to move on.
Yes, this is an update to the policy-based resource management draft. And as Diego already announced, so we had a change in the editors. So Norival stepped down and Savnik joined the editorship. Please go on to the next slide. So what's new in version 1? We added a section on resource management for VNF forwarding graphs, end-to-end considerations. And actually this was the input coming from the third adopted draft that was missing in the original compilation of the policy-based resource management draft. So input was taken from the resource management for service function chaining. And actually the scope was rather aligned for VNF forwarding graphs. And we identified and discussed with Savnik that aspects related to service function chaining is really a gap, a missing item in this policy-based draft. And also we need to discuss, and this is an announcement to the list, that we would like to see architecture considerations related to the service function chaining and policy-based management architecture. So the connection of these two items. As it was mentioned, Norival stepped down and Savnik joined. And honestly, in the past couple of months, both of us, both Norival and I, was quite busy. So I just had temporary alignment with something else, while Norival had permanently. So that's why the update in the draft is rather limited for this time. Go to the next slide, please. So regarding the status, so we started originally with the ambitious plan of including content from 3 adopted drafts. and that was basically achieved. We have the content structure, terms and definition, scope that was discussed last time in Buenos Aires. I tried to raise this topic again on the mailing list, but I haven't got any feedback or replies on the mailing list. So I would like to encourage everyone to come back to the draft scope and discuss it on the mailing list. And then, as I mentioned, the content from these 3 adopted drafts were merged, basically. Go to the next slide, please. So reviewing the next steps from IETF, so we added this resource management in service training, which turned out to be rather more focused on VNF forwarding graphs. And we wanted to include examples on policy-based resource management and implementation examples. That's missing, so we couldn't achieve this goal for this update. This is still on the agenda, but more importantly, if you go to the next slide, what we would like to do is there are some ideas to update the scope, goal, and the structure of the drafts based on the content that was coming from the 3 drafts. And we identified that service function chain control plane was meant to be included in this policy-based architecture or policy-based resource management draft, but that's still missing. So we need discussions, and we would like to extend the draft to relate to this very important topic, and to further identify the gaps, like this SFC relations. And last time it was mentioned that resource versus capability management are 2 topics which has certain alignment, but might also be different. So we need to clarify this, or at least one of the goal or one of the gaps identified is clarification of resource and capability management. Yes. We also agreed to move the draft to the GitHub so that everyone can basically pull the source of the draft and make proposals, content proposals. So the draft was merged to the GitHub. And last time we discussed that the basic idea is to submit content drafts into the Nfvrg, and then we will take this as a proposal and consider content merging into the policy-based resource management draft. Go to the next slide. And that's basically the quick update related to the policy-based management draft.
So, Robert, a question for you. So you talked about pull requests, right? So say somebody wants to submit something, they'll be happy to contribute text, but what if somebody wanted to, contribute pictures, but of course, you have to convert everything to text, but really they want to wait till, some kind of discussion happens. How do you facilitate that? Any thoughts?
Yes. The idea would be to discuss the content in the mailing list, and then once we have kind of agreement that one topic should go into the draft, then we could really work on like editing the draft, and this could be the way on the GitHub and on the pull request. So the discussion should happen in the mailing list, and with the original drafts proposed, but then the content merging, the ways of working for the content merging is just on the GitHub.
So a direct pull request in your mind is more of this pure editorial.
Yes, pure editorial.
Okay.
So no,
sounds good.
No original content, but pure editorial once we agree on some content.
Okay.
Okay, thank you very much.
Thank you, Robert. Carlos?
Okay, I'm Carlos Bernardos from University Carlos III of Madrid, and I'm going to present a short update of status of the gap analysis draft. Please, next slide. So, well, just a reminder of the history. This draft started to be presented as an individual submission back in Prague. Then it was accepted as a research group item in Yokohama, and since then we discussed a bit the structure in Buenos Aires, and there we suggested to do a restructuring. Well, this was basically suggested during some of the iterations. In the first draft, we have like the content basically around the working groups. So basically we have gaps around the different working groups and research groups that we have in IETF, and it was suggested to, okay, let's try to organize the content not around working groups, but more around topics. and also try to go farther from the current gaps and maybe look into challenges that are in the area of NFV and SDM. So basically, this is what we did. Next slide, please. So we changed a bit our original objectives. First, we had that line at the top, like providing an overview and survey of the different efforts that were taking place in IETF regarding network softwareization, network virtualization. And although we do also do that, the main objective was kind of shifted to identify and describe research challenges, and then based on those challenges, identify what are the gaps in IETF and where IETF can do work in order to tackle those challenges in the area of NFV and SDM mainly. So the idea is that we have that as a main objective of the document right now. So we have these challenges, and then based on that, we try to do a mapping and propose new activities in IETF, IRTF. Next slide, please. So this is the structure of the document as it is right now. The first part is, well, introduction, terminology, and some background. This is basically the same content that we had in the first version. So the same structure, although the content, we have been updating the content, for example, to take to consider other topics and also to update the open source initiative part that is quite dynamic. But this is kind of similar to what we had. Where we introduce all the changes is in the next slide, please, which is completely new from the previous version. So we have here now a section devoted to challenges. We started to identify there some challenges into different areas, like service warranties, energy efficiency and orchestration, multi-domain, service composition, all these topics. And within each of these sections, we basically describe what are the concrete or the specific challenges that we mean there. And in some of them, we also link those to the gaps that exist in different working groups. So basically, for example, if we think that there is some energy efficiency related or service warranty related work to be done, and we see some potential placeholder or home for that work in IETF to be taken care of, we identify that. So for example, we mentioned that for service composition, there may be work in SFC to be done, in service warranties, maybe something in IPPM related to monitoring and measurements, in network slicing, maybe in MBO3. So this kind of matching between the challenges that we describe and the potential home in IETF or IRTF. And that kind of summary of the gaps and the challenges is provided in section 5. Next one, please. These are the working groups that we consider for this matching between the challenges and the gaps. This is the list. Basically, it's the same list that we had at the beginning, although, as I mentioned, now we don't have sections per working group. So we have now these gaps merged into the text where we identify the challenges, and as I mentioned, we kind of propose new activities to be done in IETF, IRTF to address those challenges. And last slide. So in terms of next steps, well, the first one will be to get feedback from you guys on this structure. I think we try our best to actually address the comment about, okay, let's change a bit the structure and put the content around topics, which is more long-lived than working groups that may appear and disappear. Complete the analysis, of course. We may have missed some challenges. There may be some challenges that appear. There may be some of the ones that we identify. You may disagree that this is really a challenge, and it may be already tackled in some effort in IETF or outside IETF. So we would like to know. We would love to know if that is the case. So please provide feedback by sending an email to the mailing list or to the authors of the draft. And the whole goal of this document is try to make this valuable for the whole community. So there is a document where people can say, okay, these are the main challenges in this area that is not only covered by IETF, but in IETF, there may be these places, these different pieces that can be tackled in these different working groups or research groups. So that's kind of the whole goal now. And that's it. Any question, comments?
I know the room is very crowded and probably it's difficult to move around, but you should go to the mic lines. Okay, just a comment. I was when looking through the draft, I was starting to see a value in trying to attempt a publication. But I would like to see it, well, if you see it possible to structure it a little bit more around the areas. So what, I don't know if you see it possible or not, or
Yeah, that's definitely something that is worth doing. I mean, now that we have the topics, it will be much easier to match those topics with the area, so we can have like a higher layer of structuring, and then that will help to identify what are the areas where there is or there are more challenges open, also where there are more work being done in IETF, IETF, and also identify maybe potential topics that are not yet covered by any area and then maybe consider as a potential area in the future. So that I think is a good suggestion to keep on structuring the content around the work being done in Nfvrg.
please.
Hi, is this working?
Pierre, your name and affiliation, just for the people.
Pierre Lynchixia. Testing as a missing challenge. Have you considered that?
Yeah, that's, you say testing, right?
Yeah, I didn't see it in the list. I did see that you're going to push things to BM working group, but testing itself, has that been considered as a challenge?
Yeah, that's a good suggestion. We will consider that for the next revisions. Thanks. No.
No. I thought that there was somebody coming to the line, but it's
Or maybe yes.
not sure.
Yes.
Okay.
Hello, my name is Xie Tongfeng of China Telecom. Yeah, I have one challenge in my project is that configuration of the VF functions. Because in every scenario, different VF has different requirement to the configuration. For example, in the scenario of broadband mesh network, how to configure the VBRAS equipment because it has not of parameters for configuration. How to configure the parameters in a more flexible and quick way? That's one challenge.
Okay, that's also a good suggestion. So please, Juan, if you can just send an email to the mailing list so we can have some discussion based on that. On that, we will be happy to include these new challenges, of course.
Okay. Thanks, Carlos. And let me say, please send whatever the comments, whatever the idea you have to the mailing list so we can have an open and long discussion. And for sure, if you have pieces of text that you would like to see, that would be ideal. Oh, but don't eat up that much. So, well, next is Felipe could not be here. So, despite of being close to here, I mean, he's in Heidelberg. But, sorry? He's exactly. He's close but busy. Yeah. So Ranky will be presenting the evolution of this draft that was originally on containers, and now is about in general lightweight virtualization technologies. I think is maturing in a very nice way.
Excellent. Thank you, Diego. So a couple of IETFs back presented this draft. This was around containers for NFV, not broader than that, but now we are broadening the scope to lightweight virtualization technologies beyond containers like unikernels. So notably, as Diego said, the major contribution for this version of the draft came from Felipe. Unfortunately, he's not here. So next slide, please.
You have it.
For the first version, just a quick recap. The draft is all about virtual machines, challenges, and also when you move to containers, so what are the challenges and also benefits and potential solutions. Next slide. So just summarizing the latest version. So what we have is we're going beyond containers, other lightweight virtualization technologies such as unikernels and then OS tinification. And we also perform detailed benchmarking experiments, and we do a comparison and the next steps. So the benchmark setup is fairly straightforward. The latest Intel processor chipset, you can support in any of the Dell, Intel, or any other industry standard servers. So, notably, I think some of the key points here are that for the hypervisors, we use KVM, running on Linux 4.1.1. And, the point to note is unikernels are, when you're talking about tinified Linux, they're all in the context of a hypervisor. Essentially, the only case is containers where it's directly running on Linux. Go ahead. So, and also the other point to note is that for Zen and KVM, there are some specific optimizations which are done, as part of the study, not just as it is not used as. And other question, which would come up as we discuss is that we use iPerf for evaluating the VNF workloads. It is not any real VNF. So one of the key reasons is that, hey, any of these lightweight virtualization technologies are really evolving and we don't have any real VNF set. But what is a workload which is more representative of the common VNFs which are available? Then we said, hey, why not use iPerf, but the TCP-based features of iPerf, basically, throughput delay measurements, running in an iPerf TCP stack. And also, since you're doing TCP stack data plane processing, it emulates most of the real world VNFs, broad categories like firewalls or load balancers or IDS IPS. Next slide, please. So moving on to the specific benchmark experiments, we ran several. So the first one was around service agility elasticity. As you can see, Oh, okay.
as
Okay.
a set of challenges that should be considered.
Okay.
No,
Makes sense.
that's a good idea,
Yeah.
Carlos.
Makes sense.
I would recommend that you contact Ranky and Felipe about this.
I think.
No, let's move on because otherwise we are going to consume more time. No, Ranky, sit. Come on. Come here. Otherwise, no, you can stay there for hours. No. Katalin, you have in total, since you covered 2, you have in total 15 minutes for everything. So you are up to you.
Time for the first one, less time for the second.
Okay, up to you. I mean, even if you want me to start with the second, just in case, but no. Okay. Now, since you only sent me, I have to manage to show this in the because you only sent me the PDF.
Yes.
So it's a little bit more complicated.
Yeah. Okay. Thank you, Diego. So, I will be talking about the DevOps for software-defined infrastructure draft, which we updated for this 96th edition of the IETF. Next slide. So the motivation and outline for the draft is to discuss principles that are related to applying DevOps concepts to VNF lifecycle management in software-defined infrastructure for telecom, and identify a set of challenges that are addressable by research. The major areas that we identified are continuous integration delivery, stability, observability, verification, testing, and programmability of management. Next slide. So the updates in the 05 and 06 version, they follow discussions that we had at IETF 95 in Buenos Aires, and also the new charter of the research group that we tried to format some of the items so they are closer to the charter. The 06 has a very, very minor correction, and that's because of me forgetting to add the right affiliation for one of the co-authors that changed affiliation in the meantime. And the 05 section, it's the one that contains the updates for the technical content for the first time. And we have a new section of testing, and I will talk about it a little bit more in the next slide. We have...
Sorry, no, you said next slide. It was a reflex, I'm sorry.
Just checking. Then we have further clarification on the roles for the personnel, as well as trying to formulate the consideration for continuous delivery from a lifecycle perspective for VNFs. And this is Stephen Wright from AT&T that contributed most of the text there. And we also removed some of the sections like the troubleshooting and the DevOps metrics in order to improve the alignment of the text with the RG charter. Next slide, please. So regarding testing, it's very clear that testing is a key activity for VNFs in general, but also for testing in particular, and for DevOps in particular. Regarding challenges, there is about a page of text in the draft, and among those challenges are the isolation of the VNFs under test. And this is due to the fact that the environment is quite complicated with a number of management software, a number of orchestration engines that control both the VNFs themselves and the resources where these VNFs execute. And everything needs to be very well coordinated and understood for every test that is being applied. the noisy neighbors and the sharing infrastructure between the testing functions and the VNFs under test, they are a little bit related. And the challenges here relate to the fact that we are going to use resources from the same environment, both for the generation of the testing stimuli and for the VNFs that are being executed, and either performance or functional characteristics are being recorded in response to those stimuli. And dynamic scaling, it's one of the major challenges when testing VNFs. This relates to the fact that there are various ways of implementing scaling rules. Some of the scaling rules are implemented and triggered by the VNFs themselves. Other scaling rules are triggered by various layers in the infrastructure. And when we test scaling, we have to try to understand exactly which parameters and which KPIs are actually triggering scaling, which is the entity that actually triggers scaling in order to correctly allow for the tests to check particular type of functionality. And then also the testing for fault recovery is a combination of the VNFs and the software-defined infrastructure. Next slide, please. So the next steps, we would like to further align with the charter of the RG by discussing real-time properties in relationship with the stability text that we currently have in the charter. We would like to take suggestions from the meeting participants, either here or through the mailing list. So I guess we can open for questions.
So in the testing challenges, are you also considering onboarding third-party VNFs?
I'm not sure I understand.
So by third-party VNFs, in the sense, so you go through a normal certification process versus, hey, I'm bringing a VNF from some vendor, but I need an environment to support it, right? Correct.
Right.
It's not the normal certification process. So you're considering those VNFs too?
I think we try to consider all types of VNFs as part of those challenges. If the text doesn't reflect that, that's something that we shall add in the next.
The reason I brought that up was, such onboarding such VNFs specifically create security challenges. So, is your testing infrastructure catering to that? So that was more of my question.
Right. So security testing for security, that's not something that we have right now in the text. We've started with a very small section on security, and maybe we should add a little bit of text about it.
Yeah. Thank you.
Thank you.
Just before Phil stands up and says so, it could be interesting that you consider merging some challenges when the challenge lasts. It would be, again, it's if we are collecting challenges and we can put them in a single place and speed up if we can this publication, it would be really helpful in my view. Okay, so before we move on to the next one, let me remind you to sign the blue sheets. Anyone that has not signed it, but you're in the middle. So that's no, just that would help us in the coming meeting to have a bigger room, so none of you will be standing. Or I will put even a complaint about this, being people even outside on the door. That is I would say. Rewarding on the one hand as a chair, but I understand it's extremely uncomfortable. Okay, Here we go.
Okay, so the second draft, it's an example of a recursive monitoring language used for network function virtualization. And it's co-authored together with colleagues from Ericsson. Next slide, please. So the motivation of the draft is to provide an automatic way to decompose and aggregate monitoring data in different infrastructure layers and provide a way for both developers and operators to easily access the monitoring data collected in a infrastructure that contains a set of hierarchical abstraction levels. And the solution proposal is to define a query language based on an extended data log syntax, and we include predefined templates for some initial metric examples.
We're
Next
getting
slide.
serious feedback
Right.
back. Can
Oh.
somebody fix that, please?
I think that if you, yes,
Yeah.
step a little bit, yeah.
Keep the distance. Right, next slide, please. Right. So in the 0.2 version of the draft, we try to align with the new RG charter by specifying that the language addresses a need related to real-time properties of the VNFs, and it was designed to take into account all the changes triggered by changes in the VNF forwarding graphs. And we introduced a new section 7.3 that is explaining the some more advanced queries, such as how to write a top N usage for a dynamic scaling scenario. So that's it for this draft. Yeah, that's it.
Is it? Oh, that's it. Okay, that's good. Thank you. No, I thought Alistair was going to the mic, but no.
I'll go for one. So,
Okay, considerably down. Hello, this is Toktan Mahmoudi from King's College London. I was wondering if either in this or the previous draft, in any of these real-time consideration, you consider the light container, which was discussed previously, as part of that as well. Like any of these real-time consideration reflects the kind of a lightweight container in a sense.
Right, so I think in both of these drafts, we are a little bit independent of the execution environment. So whether the function is executed in a set of containers or in a set of VNFs, it doesn't really matter. From a VNF forwarding graph, as long as we have the resources, and whether those resources represent containers or they represent tiny VMs or big VMs, it doesn't really matter. From our perspective, those resources would provide a set of data, and this particular draft aggregates the data.
I mean, given that the round trip times, for example, measured was considerably lower in terms of the containers, would it make sense to link it in a way to the deployment as well?
I mean, from a deployment perspective, I think it was said by Ramki that the deployment would be on a case by case, and depending on the manufacturer and depending on the particular scenario, one of them would be adapted.
Well, I have Rankis as usual pushing me to run a little bit, but I was wondering because there are a lot of discussions about junk models and the way of even for specifying not the monitoring itself, but the collection of data from the monitoring.
Yes.
Would you consider extending the model to cover this, or this is something that you would prefer just as be as something that will be covered by someone making the request, but translating it into the language?
Right. So my understanding is that at least currently, Young doesn't support recursion.
As far as I know.
As far as I know.
Yeah.
And
we have here some
exactly.
experts that will be welcome to gel against that.
So the language that we have here is taking full advantage of recursion in order to traverse the infrastructure.
So a related question is that, yes, of course, recursion is a way of solving the problem, but just expanding on Diego's thought, perhaps writing down the information model you're looking at and also the objects in the hierarchy, and then kind of maybe leading to data model then tells you, explains you what is recursible or not. VMs, and suppose you take a VNF and a VM, so some of, say, maybe if it's overall utilization with respect to CPU, then that may be recursible, a common property, but other aspects may not be common property at all. So I just was wondering if you go with a specific example in a model, will it help in, moving this forward better?
Right. So I think we should add an example.
Yes.
That is actually handling vertical recursion.
Correct.
Yeah, because right now the examples that we have are about aggregation of information. Yeah. So it's implemented recursively, but it's on a horizontal level.
Yes.
So we should add an example for vertical recursion.
Yeah, that would be great. Yeah.
Okay. Thank you.
Okay. So, thank you, Katalin.
Thank you.
Next one in the list is Carlos again. Luis, okay. So, let me close this. This is.
Hello, good morning. So my presentation is about the draft regarding multi-domain in network virtualization. So there is no actually any new content in the draft. So we would like here today to present some ideas of architecture to define next steps and also get feedback from the audience. So next slide, please. So the rationale for the draft is basically multi-domain hasn't been a deal, let's say, in the initial steps of NFV definition. So the idea would be to explore that way. So how we can manage NFV multi-domain scenarios. So there would be, let's say, two basic approaches. One, how to leverage on infrastructure of different providers. So raw infrastructure, basically the concepts and the ideas of the slices, but also going further, how to operate network functions that are instantiated by these other providers, and in such a way that one provider can operate and manage virtual network functions that are provided by other remote provider. So basically the idea of exploring this way is to look for the capability of having programmability, flexibility, and automation in scenarios that exceed the borders and the frontiers of one single provider, and also to accelerate, let's say, the deployment and reduce the time of providing services once we have to deploy services out of the scope or out of the borders, let's say, of a single provider, basically. So next slide, please. So this is the well-known NFV reference framework. I will not spend so much time here. This is just to visualize that the initial conception of this architecture was focused in single domain scenarios. So multi-domain interfaces are not present in this architecture, and the idea basically of this draft would be to explore these interfaces, the capabilities of these interfaces, and the required information that we need to incorporate into them for facilitating this multi-domain approach. So next slide, please. So the broader statement, this is maybe a little bit redundant, is because we will have availability of infrastructure in different domains. So the idea is how to make use of this infrastructure, these slices, or even going beyond, how to exploit virtual network functions and services in such a way that these virtual network functions could be provided by these other administrative domains. So nowadays, there are not established mechanisms for providing access to multi-domain environments, not for sure in a standardized way. This is key for having interoperability and let's say, industrialize the capabilities of instantiating these virtual network functions or the usage of these resources in multi-domain scenarios. And one example would be to facilitate portability of virtual network functions across different domains. There are other examples, like extension of services in footprint where one provider has not infrastructure, for instance, etc., etc. So next slide, please. So this is probably the most relevant slide of the presentation. This is a situational figure where basically we try to show all the possible combinations of these multi-domain scenarios. We go, let's say, we try to cover the string cases that could be, for instance, the provider domain number 4, where basically this provider has only capabilities of service orchestration. That would be somehow a reminiscence of virtual network operators that are using resources of other different operators that they have agreement with. And also the other string case would be the provider domain number 2, where basically this provider domain is an infrastructure domain putting in value their infrastructure and trading this infrastructure to other providers. All in the middle are combinations of potential combinations in this relationship in multi-domain scenarios, where these domains are handled by different administrations. And you can see relationships between service orchestration, resource orchestration, and different interactions among them. The idea is each of these providers can have its own tenants, and the tenants can take profit of the resources of other available in other domains through the agreements that any of these providers could have in this ecosystem, in this multi-administrative ecosystem. You can see there are different interfaces between the service orchestrator and the resource orchestrators. The idea is here to explore as well how different should be these interfaces, either being internal or external to the different domains. Probably the level of abstraction should be the same. Maybe some details could be different. An analogy for this could be the case of eBGP and iBGP. So it's the same protocol, but different policies, different details, but the same structure. Yeah, so basically the idea would be to explore all these interactions and to try to identify the capabilities of those interfaces to make these multi-domain scenarios operational. So next slide, please. Oh, okay, yeah. Here, the highlight that we are working on this architecture in the 5EX project, which is a European project in the framework of IEPP. And basically, we define here an ecosystem, an exchange, an evolution of the traditional exchange ecosystem. That could be, let's say, the starting point could be the internet neutral point. So going further and trying to evolve that to an ecosystem where you can trade not only traffic, let's say, but also network functions and slices. Next slide, please. So the next steps would be to keep working and improving the draft for sure, also taking into account the feedback that you could provide for sure. So take into account the latest developments in ETSI and ETB. There are some work that is being presented in some of the reports. The IFI 009, for instance, is presenting some ideas to this respect. Include evolved architectural proposals from 5EX, so the work in the project, but also from other relevant efforts or sources that you could raise to our knowledge. As part of the project, we are implementing these concepts of the multi-administrative domain interaction and the definition of the interfaces, and we will produce experimental results that will be documented for sure here. And also the outcomes of the project will be released as an open source implementation, so it will be available to the community for experimentation and testing. And last but not least, we'll gather the feedback from the group and having your feedback. I think this was the last one. So if there is any question.
Yeah, thank you for your presentation. I'm Seljan from Sangigan University.
Can you repeat your name?
Yeah, I'm Seljan from Sangigan University, and thanks for your presentation. And I think that nowadays this subject takes some importance. In terms of that, is good. Here is two key questions: is that when you say, and when it comes to the multi-domain, actually you mentioned about the multiple administrative domains, but actually this consider such as end-to-end network slicing concept, considering different domain in terms of the RAN cloud, edge cloud, and core cloud.
Yeah, so your question is the multiple domains consider different...
The multiple domain can be interpreted in terms of the different end-to-end network concept domains.
So I'm not sure if I'm getting properly well the question. You refer that if these different domains are different administrative domains handled by different...
Only administrative domains, right? Not just a RAN domain and the edge domain in the not core domains.
So are not necessarily network segments, if you refer to that, but pure networks, let's say, pure different administrative networks from different operators, for instance.
Okay, and another question is that what's the purpose of this draft? Is just bringing just the requirement and the problem statement, or additionally proposing some available technical approach for this multi-domain?
The idea would be to explore how these interfaces should be, what kind of information should be interchanged through these interfaces to enable these multiple administrative domains, and also to explore architectural capabilities. So from the figure of architecture to realize how feasible are the different interactions, how different or equal should be those interfaces, and what would be the information that these interfaces could support or could handle, let's say, to make this ecosystem work, make this ecosystem operational.
Okay, thank you.
Question. So the 5G EX project, so kind of where is that in the evolutionary phase right now? Is it defining all these interfaces, or?
Yeah, so it's basically defining an ecosystem where different providers meet together, not necessarily physically, but let's say, enable, let's say, the trading of services, of slices, for instance, or even DNFs. And the goal of the project is to do some innovation on this scenario, to define these interfaces, to identify mechanisms for resource orchestration, for service orchestration in these multiple administrative domains.
We are cutting the line with Costas. No. Andy, go. No. I'm saying that Costas is the last one.
Hi, Nfvrg. So your MP NFVO, that's an extension to NFVO that supports NFVO to NFVO communications?
Yeah, it would be an NFVO in a multi-provider environment. So you have this kind of recursiveness between with other NFVOs, either service orchestration or resource orchestration, in order to make this to enable the service provision in these different domains.
Kostas Petikousis, TravelPink. So I have an editorial suggestion for the slide number 5. I counted at least 5 acronyms that I have no clue what they mean.
But so this is because you have not read.
That's correct. That's correct. So I would like to ask, who has read the draft? Please raise your hand. And is not an author. And does not work for the same company. So Steven has read the draft, right? Good. Okay, so that's one thing. The second thing is, I think that the confusion is correct. My understanding from just reading your webpage, I don't understand what is 5G about this. In the sense that...
But let
me, 3 seconds more. I think that's where domain may mean something specific to different people. And I think what you're discussing here has to do more with what traditionally we will say as wireline part of the core network, let's say, or perhaps a GRX or something like that.
Yeah, that will be probably the starting point, the concept of IPX or internet neutral point and so. But this is just, let's say, the starting point. The link with 5G is the capability of trading slices, so deploying services where you don't have footprint, for instance, for doing that, or even you have footprint but not enough resources for doing that. Also, provide, let's say, transport capabilities in a dynamic way that will be motivated by the needs foreseen in 5G. And so if you refer that there is no link because this is not radio specific, okay, this is not radio specific, but it has to be with all the dynamicity that is expected in 5G.
Right. So perhaps it's more, let's say, wider than 5G, let's say, or not so 5G specific. But then I'll let Diego explain.
Yeah, and regarding the administrative domain concept, this you can take a look at RFC 1116, and this is the same administrative concept in the domain that is considered here in 5G.
What was the RFC again?
1116.
That's pretty old, eh?
Yeah.
Well, IP is older, if you think, and you keep using it. No, just as a commercial, if there is a special session that is called precisely for the coming meeting in, well, 2 sessions that are called for the coming NFV meeting in Sofia Antipolis, precisely to analyze the connection between the 5G concepts and NFV and how one influences the other and vice versa. And apart from that, well, yes, I would say that in general, what we are doing here goes beyond 5G, but on the other hand, many of the research that is being presented here is funded by the 5G initiatives, and we have to pay honor to that.
Okay. Thank
Thanks,
you.
Luis.
Thank you.
Next one is you, Pedro. So.
Okay, well, you put the slides on. Good morning, Pedro Aranda, Telefónica Research and Development, and this is part of another 5G project called Superfluidity.
Sorry about that.
And anyhow, first slide. So the rationale is that if you've been confronted with a virtual network function descriptor, a VNFD, you will see that if you're in a clear and clean state of mind, you're not going to be able to understand it very easily, and that we actually need something that is more catered towards having the possibility of reusing VNFs in when you're building more complex VNFs. So VNF, the descriptors currently go against one of the nice things of software development, and that's reusability. And why? Because normally you would be more oriented to reuse something that you understand, as opposed to try to reuse something you don't understand. Next slide, please. So confrontation, a graph, and a graphical figure you can easily understand. What is on the other side, I think, is a bit more complex. And if we had problems with Yang being recursive or not being recursive, I can say the same for YAML, which is the way VNFDs are being written in many environments. Next one, please. So since we've seen that these descriptors are not easy to understand, why not use something which was already here last summer in Prague, which was called the network modeling language NEMO, to do that? Because this language has 2 things. It's human readable. VNFDs are currently with YAML, but more importantly, it's human understandable. You can really read something and understand what is below that. So basically, for those who were not present last year in Prague and did not come to the BOF where we were discussing these things, NEMO is a well-structured language, like any high-level language, high-level programming language you might see in normal programming. Next slide, please. So the thing is, on one hand, you have this wonderful NEMO, which you can really understand. On the other hand, you have a lot of things that are already there, written with things like for things like OpenMano, OpenSuite Mano, and other environments. And you should not be just taking all that work and throwing it away. You should be able to reuse all these things. So in the draft, what we are actually exploring is the way to reuse these things and use Nemo to do the more hard part, which is to write the service graph with it. So there was one of the components in the language that we proposed to use is the node models, and this would open the door to recursiveness. Next slide, please. So this is what we actually want, taking from one of the documents from the Nfvrg in the manual part. We want to find an easy way to describe the VNFs as possible. So next slide, please. So actually, we propose a two-step process to do that. A first step where you actually take the VNF descriptor and use it as you would use, for example, assembler language in higher level programming languages. So we would actually want to import those things into this higher level language you can understand. And for that, the only thing we really, after exploring a bit, the only thing we really saw is that we needed to define somehow a connection point that would map the significant virtual interfaces within the VNF towards something you can reuse afterwards. Next slide, please. And once you have this, then you can really write models for nodes that are more complex. You can import your VNFs, and then you have something that you can actually more or less read. You see, you have, for example, two nodes that are going to be part of your new node model. One is something I called a sample VNF. The other thing is a shaper VNF. We have a connection point for the input and the output, and then you have the connections from the different points within the slide. And this text would translate into, please, next slide, something like this, which is more easily understandable. But not only that, it also allows you to use something that you have already defined, this node model. You could reuse it in order to make a new, more complex model out of that. So next slide, please. This is the last slide, as said, small commercial. This is part of the work we're doing in the Superfluidity project. There we have something we call RFBs, reusable function blocks, and we are using this as part of our way of describing this reusable function blocks. And work, please, the next steps, please, the draft is there, read it, comment it, and help us improve it. And if there is a suggestion of where we could even integrate with other drafts, I've seen the other reusable things, the other recursive things for management and so on. So if there's a way of putting all these things together into a working item, also happy to open up and collaborate with other drafts. Thank you.
Okay.
Okay.
You made things simple.
Yeah.
Okay, next one should be Jose Bonet from Altis Labs. Since he's not here, it will be me. Sorry again, when talking about 5G. So no, I'm not going to talk about 5G. Talking about something that has been funded by 5G anyway. So it's a concept about using something that we call, it comes from a project that is called Sonata, that is willing to build a pluggable, flexible, extensible, and dynamic orchestration framework. And the idea is that, one of the basic ideas here is to use a mediation system that we call the gatekeeper for doing everything. I mean, DevOps and other things, and it's precisely to introduce you to the gatekeeper. Next one, please, Frankie. So basically, Sonata, one of the things is that identifies this set of components for supporting DevOps, essentially a set of catalogs that are located in different places in the infrastructure. and where you store the information. And somebody was talking about configuration precisely. One of the ideas is that you have not only the images or the containers or the whatever, but you have the mechanisms, at least the mechanisms for making the configuration. Then you have to particularize them to a particular deployment. And you put together, on the one hand, the service development kit, so you have the elements to build the software pieces that constitute a service or a component of the service, as in the case of the VNF or the VNF components themselves. So you build them consistently with defining the service. And on the other hand, what you have is a service platform that takes care precisely of taking the service defined using the SDK to instantiate them, to make the actual deployment, and to collect information and put it back to the SDK, so the developers that are connected directly to the operations can get feedback of how the operation is going. And well, for sure, you need infrastructure. Without an infrastructure that is there for running, you don't have anything to run on. So look at this as a way of thinking in terms of DevOps of a VNF infrastructure. Next one, please, or an NFV. So basically, the idea is that, and the proposal, and the main proposal here, is precisely to have a mediation system between the SDK and the service platform. So it takes care of validating the services and performing the necessary checks on, basically on who is entitled to do what. So there's a user authentication authorization, whether you can actually make the deployments because it's safe as far as you know, in terms of verification and attestation of the package. And in terms of somehow, well, I would not like to use the word orchestrating, so somehow scheduling the appropriate ways of accessing the interfaces in a secure way. So an operation that has been invoked by one developer doesn't affect the running platform when you are committed to do so. Because, well, as you all know, we're talking about very delicate deployments, and you have to be careful about that. These are the essential roles of the gatekeeper, and we are working precisely, inside the Sonata project in that way. And our proposal would be precisely to explore the implications that such a mediation platform and such a mediation platform has, and think whether precisely proposing that mediation mechanism makes sense in general for supporting. Next one, please, DevOps in NFV. Well, apart from that, this is something, I will go through this very, very quick. If you're interested, we can talk about that. We have several people in the line. Basically, the idea is that it's not only when we're talking about making a secure scheduling of the operations, one of the things that Sonata has is a pluggable manual interface, so you can put additional plugins for managing, in particular, on the one hand, particular functions, on the other hand, for performing particular operations that are especially relevant. And precisely one of the things that the gatekeeper helps is precisely in controlling what you plug and what you invoke for certain for particular operations. And well, this includes it is the gatekeeper becomes even more essential in terms of security, in terms of stability, and in terms of something that is very important at the end, which is management consistency. So you are able to understand and trace back whatever has happened in the orchestration. Next one, please. And if we're talking about recursion, and it is very, I guess, it's connected somehow with what Luis was mentioning before, the idea precisely is that a mediation element can act precisely as well, supporting the recursion, because in the diagrams, this has been part of some initial discussions between both projects about how you can use a mediation element precisely to support vertical recursion. So whenever there is a requirement from the what in the, sorry, Costas, when we were talking about the NSO and the NSO talking to the RO, and I won't say what they are just to keep the mystery on. So the network service orchestrator talking to the resource orchestrator can be by itself another network service orchestrator at a lower layer in the recursion. And the idea precisely is that mediating that by using the same constructs we are proposing for connecting developers to the service platforms should be the natural way of doing so. And this is something that it is worth exploring as well. Next one, please. So just our idea before anyone stands up and asks what is your purpose with this draft? Well, essentially is the idea that to acknowledge and to elaborate the idea that you need a trustworthy cycle for supporting DevOps, that a mediation element probably is the most natural way of providing that. And well, it is not only about, as I said before, when you start thinking about what mediation provides you, it's not only about these DevOps or development and operation connections, but you can think about extensible management or recursion or even other properties that are worth considering. What we want to do is consolidating the concept of the draft around this idea of the mediation elements, mostly inside the project, and we will be in the position, I hope, to report something else, probably not for Seoul, probably for the IETF meeting after that. And the idea is that, well, connect with other drafts that are addressing lifecycle aspects, like and not only in the side of the lifecycle aspects, but as well in the side of I mean, when it comes to DevOps, but when it comes to the precisely management and orchestration. And well, in a few months we will be talking, and probably will be here, or Jose will be here asking you for adoption. But let's go step by step. That's all. No, keep on.
Roberto Eriksson. So very nice draft. That I really wonder that it looks to me that many of the work are replicated. So there are DevOps drafts already, and then there's recursive programming or draft already adopted by the research group. So I would really like to propose to consolidate these kind of contributions and try to discuss and
no, definitely.
Ideas. Yes.
That's why we have here that, yes.
Yes, but you mentioned adoption and these kind of things.
Well, no, yes. I mean, not that. Well, I have in mind this idea we had when we adopt a draft, we try to point it to a particular area so it can be merged and aligned with the other ones. We can do it before or afterwards. If you want, we can start talking about making them converge in the.
So definitely, the recursive approach is really welcome.
Yeah, definitely.
And the DevOps draft will definitely benefit.
Sorry?
And the DevOps draft will definitely benefit.
Name, please.
No, I don't think so. No, sure. No, that's our idea. In practice, if you read the document is intentionally not detailing the analysis of DevOps and requirements or whatever, because we assume that it was going to be very likely merged with another document. Seriously.
A request to anybody on the mic, kindly say your name. There are note takers who need to hear your name. So
Kostas Pedikous is traveling.
Thank you.
So I think then a reference to the DevOps draft would be.
Oh, yes. I mean, you mean in a 0-1 before we go on? Yeah. It's
Stephen Wright, AT&T. So thanks for another interesting draft. I think it's similar sort of comment about aligning with the DevOps draft. And I would caution between, or at least what I would like to see is more definition of the functions of the gatekeeper rather than proposing a specific architecture. I think there's lots of interesting concepts there in terms of validating the the material coming in and being ingested, and trying to get a clear definition of what those validation steps and phases are is a good step. Getting clear definitions around that step would be a real useful contribution. I think the other thing is this draft was very focused on the network service rather than just the VNF, and maybe there's some separation of parallels.
Lower a little bit, yeah.
Maybe walking before we run, kind of.
Makes sense, yes.
Dejan Bogdanovic, Volta. I actually have a reply. I would prefer that you stick with the architecture and not going into particular functions, because if we try to come to an agreement what functions we will need, it will really hinder us in the process, because we will not be able to reiterate for the functions that we are needing.
Which functions you mean? Okay.
That was reiterating, because this is what also we are seeing now in the young modeling, that as we are going forward, some of the drafts are not ready, and then we are getting stuck for months until the other parts are ready. So for that reason, I would prefer to stick with the architecture.
You have to make decisions if you're building things. I'm just trying to distinguish between if you're proposing an architecture, that's a concrete thing that you're trying to build. If you're trying to elaborate research challenges, that's a different list. And that's, I think, where this was going if it goes into the DevOps draft.
Well, I wonder whether if we go for a merge and we put together everything that we have around DevOps and how to enable DevOps, we can find something that is in the right midterm for both, hopefully.
Perhaps that's a list discussion, David.
Sorry?
Maybe that's a list discussion.
Yeah. No, for sure.
Yeah.
Bring it to the list. The list is a little bit, not as alive as I would like to see. So
yeah.
Bring it to the list.
Thank you, David.
Okay. So now
you have a lot to go.
So now we move to the probably the block that you all were waiting for, which is about the new reports. And so we have quite a few interesting presentations and a demo full of robots over there, just for you to know. This is a teaser, Robert. So first one is Michael Lazar, who made a presentation like this a few months ago in an NFV meeting, and I think it's extremely interesting. We will have 1 hour, so it's.
I'll move it along.
Okay. Let me. Here we go.
Thank you. So a little bit of a different type of presentation. This is informational results of what happened when we actually tried to implement some of the components that are out there and some of the things that we found from a security perspective. Next slide. A standard disclaimer from the ETC, because this was an informational submission. What's important here is things are constantly changing and evolving. So the information here may already be outdated, and there may be some new things that have come up. Next, please. Just a little bit about it. This is taking commercial equipment, putting it together. We try to use, from an NFV perspective, OpenStack, Open Daylight, OP-NFV implementations. It is Intel-centric. That's what was available. It's not meant to be exclusive, and we're aware of other architectures and issues and/or solutions. I try to point them out. From an ETC perspective, they have security use cases. This document is not, a presentation is not about any particular use case. It's about when everything's put together, what happens, we look at it from beginning to end. Next, please. The obligatory architecture slide. We've been talking about the virtualization architecture in the lower left corner and the implications of it. You can go ahead, next slide. A couple of very quick terms and definitions as we're going through it. So we'll be talking a little bit about attestation. So in the context of what we're talking about here, attestation is, A launches B, B launches C, but who is in control and who says that A is actually valid? So there is hardware attestation. The idea is that there is a piece of equipment, piece of actual hardware somewhere that can be used as the anchor or the root of trust in these solutions. If you want to go next. Another definition, just to get out there, is remote attestation. And remote attestation is when one system or various components can now say, not only, I'm trusted and here is information that I'm trusted, and be allowed to communicate that what's going on has been verified. So when we started looking at this, one of the things we quickly found out is that virtualization shouldn't be too much of a shocker for anyone in the room. Brings a whole new world of challenges, especially from the security implementation. One of the biggest things is the concept of trust. And that is that in today's operating systems, most operating systems, I should say, there is a concept that if someone is doing something, if the kernel is performing an operation, if it's retrieving or putting information out on the network, by default, it's trusted, right? That's the idea, that's how it works. This brings, I believe there's a presentation on Thursday that's going to talk about this as well in another area. I think it's a very interesting issue. Because of this implicit trust model and then the implementation of it, there has been a lot of potential attack vectors that have been opened up in the virtualization world. And now what we have is a lot of technologies technologies trying to mitigate some of these issues. So I've listed a few of them out here. So we have things such as VTD, which is preventing, unfettered memory access. Authenticated boot, which we'll talk about in a second, the TPM module, which is a way to do attestation from a hardware level. You have the trusted boot, and then we have some confinement technologies that have been built into Linux over several years and are well regarded. SE Linux, Nfvrg, AppArmor, SecComp as well, and Intel has released a open attestation toolkit, OAT, since been superseded by another piece of technology, but the idea there was it can be used to build remote attestation. There are other technologies that are currently available and are emerging. I've listed a few of them right here. Security guard extensions from Intel is coming out. There is the trust zone architectures, which you find in other CPU architectures, which is very interesting. So next slide, please. So one of the things we started finding pretty quickly in putting this together was the danger of using, again, commercial available components, that there is always a danger of bad BIOS, modified hardware. This is intentionally, maliciously done, and there have been real world attacks that have been performed this way. So one of the ways to deal with that is, well, verify the hardware platform, right? Use that attestation, make sure that no one has tampered with anything. There has been certainly side channel attacks under hypervisors that have been put out there where before the initial system is loaded, another thin layer of hypervisor gets loaded. And what can you do to stop that? Well, there are ways of preventing unauthorized memory access in VTD that should be used, obviously. SE Linux, from the breakout attack perspective and the confinement technologies, is very useful to make sure that systems are only doing what they're allowed to do, or virtual machines aren't reaching into areas or doing functions that they're not allowed to. And again, it's pretty robust technology. It's been around for a long time. Again, I talked a little bit about the SRTM. This is probably the most mature technology. This is trusted, straight from the Trusted Computing Group, which is by reference incorporated into this. So the idea is that you use the ability to verify the hardware, make sure it has not been tampered with. Intel over the last several years has introduced additional technology for producing a dynamic root of trust, which is now can you not only authorize or verify, I should say, attest to the hardware, you can also attest to the operating system, if you will, the hypervisor. So now you're knowing that the hardware itself hasn't been tampered with, and that first hypervisor that's being loaded also hasn't been tampered with. And this is the concept of, again, where remote attestation really comes into play. If you want to go to next slide. So now that we've implemented all the best practices that are out there, we put this together. We have a modern OpenStack flavor running. We are using everything we can possibly find out there. Everything should be good. We have verified hardware, verified software. And this is where it started to get very interesting in what we found. So one of the first things we came across is from how the OpenStack architecture, OpenNFV, actually implements the concept of a trusted host. And it's actually a flag that is not necessarily built in at a very low primitive level. It's an overlay onto the system. The challenge is if while it's running, if you change the flag, it doesn't necessarily have an impact. So because it's not built into the scheduler, it's subject to manipulation out of it. The attestation server itself is clearly attack point, and it's using certificates, and all the usual challenges that go with using certificates come into play. Another thing we found, this was just talked about, was that the current OpenStack architecture supports a binary trust model. And so when I talk about the trust model, I'm talking about a security trust model. Hosts are either attested and verified that they're good or that they are not. There's no concept for any multiple trust models or hierarchical trust models, which are, one could say, required in telecommunications, telco, and critical infrastructure situations. One of the interesting things we also found is that you can designate a virtual machine to require a trusted platform to launch. So that makes complete sense. You have a sensitive workload, you want to run it on a trusted host. But by design in OpenStack currently, untrusted virtual machines will also launch on the trusted hosts. I'll let you think about that for a second. It's interesting. And again, that's by default and how it works. Currently, from a attestation, in other words, again, verifying the hardware has not been tampered with the current solutions that's out there, only the compute nodes can be attested and remotely attested. So you're verifying again that the hardware hasn't been touched, the operating system hasn't been touched, and then it's performing some functions. That's only available for the Nova right now. So when you think about your SDN services or everything else running on Neutron or replacing Neutron or working with Neutron and any other services that are going, you have critical features and functions that you cannot verify that the platform and the operating system they're running on have not been tampered with. Say it's a potential issue. The virtualization administrators, this is also just a big problem across the board, that the person running the virtualized environment has a lot of power. When you had individual systems and you could have multiple levels of administrators that only have access to certain systems, you have this sort of built-in segmentation. Now you have a lot of components running in a single environment or single set of an environment. And your admin who might be performing one function may have access to a lot of systems and a lot of capabilities they not necessarily should have or authorized to or be trusted with. The next slide, please. So a couple other things that we found. So even in the architecture today, when you have a trusted host and you're using the security server and it's implemented properly, if you revoke that host's trust, anything that's currently running on that host will continue to run. So if you now have something that you've known is compromised and you want to revoke it and say, nope, from a hypervisor perspective, from a scheduler perspective, it on its own won't do anything and change what's going on there. I talked about the OAT and the security station itself becoming the target. You know, something's always the target, something's always a bottleneck. So you're putting in remote attestation, not having federated architecture for remote attestation says you now are moving an attack point to a single device. That system better be well protected, which is interesting because the current implementation that's available requires SE-Linux to run disabled or permissive on the security server itself, which goes to a whole nother problem. Is what we found is very frequently in the OpenStack environment that these confinement technologies, so whether it's AppArmor, SVirt, SE-Linux, they're either set to permissive as a requirement, disabled, or when they are in place, they are so generic and so general, they're not giving you much protection at all in doing it. Shared memory. One of the benefits from virtualization is being able to, get a higher leverage of the resources. So a particular issue that we found to be rather interesting is the sharing of memory, and this presents some very, a very real and potential security issue. So again, in telcos, if one of the recommendations is, turn it off. Out of it. There are practical demonstrations. There was a paper put out late last year showing that address randomization was broken or could be effectively hacked pretty easily by a standard machine running. And in one instance, with the author's claims with Windows 2012 is about 5 hours. And leveraging this, Linux takes a little bit longer, but it's something to be concerned about. We talked about there were some performance benchmarks that were shown before, and I know from Etsy's perspective, from Nfvrg's perspective, from OpenStack's perspective, and continually improving the networking performance is high on everyone's mind. One of the things we found is that a lot of, and I'll say specifically like in the DPDK toolkit, also requires those confinement technologies to be disabled. There has been some improvement in that lately, but where certain configurations now can function. But if you think of all of the vendors who have products out there based on this, what can be done to get them onto supported platforms where confinement doesn't have to be disabled when you're running in the environment? Hypervisor choice matters quite a bit. So we've seen that as, again, a lot of the higher performance or high performance toolkits looking for QEMU running, which is fantastic, except it has known security issues and security warnings that are out there. And so the question is, when you're implementing this, have you gone through the necessary steps to harden it as much as possible? Containers are fantastic, but of course, one of the biggest challenges or potential challenges with containers is if the underlying kernel has any issues, security related, that translates to direct access back up into the containers since it's all shared. And again, something just to think about. Next slide, please. So again, virtualization, just we found, again, not unexpected, but lots of new challenges that are out there. So when it's being implemented, a special care should be taken in what's going on. The hardware root of trust is something that we're not seeing implemented enough out in the real world, where people are putting NFV architectures out there. They're not doing attestation. They're not taking advantage of what's currently available. And that's something we believe that really should be addressed. We've seen, commercial vendors shipping systems with basic technologies like VTD. Again, this is preventing raw memory access, not enabled in the BIOS. So again, from a community standpoint and from a responsibility standpoint, making sure we get the word back to all of our vendors, turn on the basic stuff. It's kind of important when you're shipping it. The OAT from Intel was released with the BSD licensing model. It has not been widely picked up and used, which is a shame. Intel did put it out there with the hopes that people would go and build really nice and interesting security solutions on it. I know that they're re-releasing a new product called CIT that is supposed to address some of these issues and concerns, and we look forward to working with it. This binary trust issue is, I think, a very big concern. Forgetting this fact that it allows untrusted workloads to run on trusted systems. In telco environment, only having a single security zone from a hardware level, from an attestation level, we believe leads to a lot of potential issues. And that's, we're talking about multiple domains, et cetera. So this is something that should be looked at and addressed. We are trying to continually work with the open source communities to address some of these issues. So I would encourage everyone in here, if and when they can, to bring it up and have them think about it as well. So, thank you very much.
Okay, now let's see if you are being scared enough to go to the mic and say something.
So question, so we talked about all these security issues. Do you see them as coming from more of insider threats or outsider? What is the source of these security threats?
The security issues themselves, it's about when they're being layered together. Any individual one itself isn't particularly bad. It's what happens when you start stacking them up. So, people need the performance and networking, so they're willing to turn off, confinement technology. And they'll think that, okay, well, I have a trusted, I'm on a trusted host, which is actually the official way it's presented, only run trusted workloads on something using one of these accelerators.
No, I completely understand. So the knobs are definitely open, but where does it really, where does the security problem start? It's just basically the insider going rogue or versus an external attack. Where do you see the real problem happening?
Both. That's a whole wonderful discussion to have about what actually happens. So there are both. There are external attacks. Again, the concern in telco or any critical infrastructure isn't so much the individual hacker, it's nation states. So, they have very sophisticated tools to go after these things.
Dejan Bogdanovic, did you think about lawful intercept and how to solve that in this environment?
Lawful intercept is a very hot topic in the at the NFV security group. The entire group is working on it with some recommendations. The normative document, there's a few reference documents regarding it, but we're hoping to have the normative document, which would be Sec 13, published, or I should say draft published and available for more general comment before September.
Okay, thank you.
Thanks. That's a big issue.
Dave Dolson, Sandvine. You're talking about trusted guests, I believe, right? I'd always thought that you weren't supposed to assume anything about the guests. So like the hypervisor was supposed to enforce whatever security was required, like that it would be, it's kind of like you shouldn't trust your users to write good code. You should always catch their exceptions in an operating system. But it sounds like you are saying that.
Well, more specifically, try to step back here. More specifically, so you can say, or you can go through the steps of saying this host has been physically verified, and then what that specifically means is it's gone through a process where it hasn't been tampered.
Wait, host or guest?
The host, and then with certain technologies like Intel TXT, you can take it the next step and say that first hypervisor, that it hasn't been modified, it's loaded, it's good. And the idea is you have a system, if you will, hardware and software that's running that is trusted. Specifically about the guests, what happens is the catalog, people will put in a catalog, ideally some authorized administrator will say, this is a sensitive workload that needs to only run on trusted hosts. So the challenge then, in what we found is if say you have 100 hypervisors, 20 of them are trusted, 80 of them are not. When you have trusted workloads, they'll only get scheduled on those 20. But that functions as designed, it makes complete sense. So that could be your HSS or maybe an encryption server or something like that. The challenge is that by design, it'll also allow something that hasn't been said as sensitive or needs trust to also run on it. And that's where that problem resides. Theoretically, that by definition, that kind of breaks the concept of trust.
Okay, so this is kind of unrelated, maybe it's a different question, but so from a guest should be able to determine within its own code whether it's running on a trusted platform. For example, if I'm running a licensed server and I want to know whether I'm,
When the guest is, in this architecture, the OpenStack, when a guest is added to a catalog, someone is saying it needs to run on it in a trusted environment or not. So it's outside, it's external to the individual guest. It's a metadata, if you will, related to it.
And I dare to say should be, but anyway, that's something that we can discuss in more detail, where the trust and who access the trust statements.
Stephen Wright, AT&T. So thanks for an interesting and scary presentation. So are any of your recommendations captured in some best practices somewhere or in some test scenarios at OPNFV or something similar?
They are captured this is a subset of a document that was submitted to ETSI for informational. They are being directly captured in more of the ETSI documents. And for the normative document, some of the specific recommendations which are easy enough to implement, they'll fall into the shalls, of it. So it's certainly not secret. We've had communications with OPNFV, with Luke Hines. Then we've also talked with the OpenStack community, talking with them as much as we can. Because again, some of these issues are actually not very difficult to fix in software. Some of them are more difficult, but what we don't want to see is, someone saying, okay, I can fix this and fork it. And then we have what we're trying to avoid. We don't have a solution, we have many solutions. So we want to see the community say, yeah, you're right, and try to address this. So again, it's being published in ETSI, it's being published specifically in documents, which will link back to the source document out of it. If there's another place you think it should go, please let me know, because we're happy to put it out there.
Also, one last comment, be worthwhile getting this into challenges document. So our challenges effort in Nfvrg.
Happy to do so. I'll work with you on it. Thank you.
Carlos, you're going out from here with a pile of work to do, I'm afraid. Yes. Well, the next one is Angeles. Her idea is precisely to bring some, to mix some ideas on network coding that with the idea of virtualization, which is something that I think it will open quite interesting paths for further work. But I'm afraid we are running out of time. So
I know.
If you can be as brief as possible, please.
Okay, so I think given 2 minutes and maybe now even less. So I identified 3 messages I wanted to read here. First, to introduce the concept of network coding. Since for this I would need days, then I would just highlight the essence of the concept that is relevant here. And then, okay, so the relevance is in this slide. So basically, first is the main theorem based on which all your work is fundamented, which is the max flow min cut theorem, first proved by Elias Weinstein Shannon in '56, and the same year for Fulkerson, which is maybe what in the version you know. So your work, the work mainly in internet, is based on the assumptions for this theorem, which is that the network information flow is based on the energy conservation law. This is what is the basis of routing. And as I say here, is the basis of current internet, so store and forward nodes. Now, in 2000, there was this follow-up theorem, which is the max flow min cut, but for multicast transmission. So the main thing here is that in order to have capacity, to get all the capacity of a network, the max flow min cut alone doesn't provide you with this. So what you have to assume is that now the network information flow is no longer based on energy conservation law, and so the network nodes should not be only store and forward, but should do network coding. Next. So what does it mean? It means that you are considering network flows as a physical thing. What network coding says is that you shouldn't, or that you can consider them as something abstracted. This means that you can have, for example, a linear treatment of your flow, meaning that you represent the packets, the information packets that now you don't care about what is inside. You abstract this in some mathematical term. So then what you can do is to manipulate mathematically the network information flow. and can be done in an easy way, meaning just with linear coding, meaning you have the mathematical model of what you are transmitting, and then you can manipulate them. And moreover, not only you can manipulate them in some linear way, but the way you do it can be completely random, meaning that the coefficients where you combine these packets can be selected randomly. And moreover, all this gives you a capability to have purely algebraic means to design all these things, meaning that networking becomes something else, not only protocol, but you can treat it mathematically, so that what you networking becomes something like solving linear relations between input flows and output flows. Next. So basically, this is it. This is from this paper here. What you can do now is take some part of a network, for example, that one on the upper left part. Then what you can just do is, okay, I have my input flows, I have some network it goes through, from which I may not know the topology, and the output flows. So then what now I can do with network coding is to abstract away all these things and have a matricial representation of that. So it's like we move from treating networking with some analytical tools to treat it with some other analytical tools based on matricial and algebra, from which there are many results that we can use to optimize networks. So basically this is, for example, here, M would represent the network, and in addition, you can factorize the network, and you can do many things this way. So next. So that's the essence I wanted to mention about network coding. There are many results already available, and with very well known by now general benefits, and of course costs. There are always trade-offs here, but for the benefits, it's for sure increases throughput, reduces delay, allows you to do a better use of network resources, efficiency. It reduces the computational complexity compared to routing. You have also robustness and detection of link failures, and also that's why this is related to this working group, enables in-network engineering of packet flows. And this concept of network coding is very broad, so it can be applied to any communication layer, including physical layer. But this is another word. Now, some costs, some trade-offs you have to think of. Of course, there is some additional overhead and complexity due to that you have to somehow taking care of how you encode. Then the overall cost here is that requires novel design paradigms, and possibly, which means that possibly you have to do a gradual implementation. You cannot just get rid of all the nodes that exist in the internet that do a store forward and say, no, now we need to do a processing in the nodes. No, but there are ways to do a gradual implementation, and one way is what you do here in this working group. And there are also patents already for some things in some countries. Next. So this, of course, there are already examples. It's not that all this is theory. There are a lot of theory. There is a lot of things that already work. For example, it can help TCP to reduce, to lower congestion and to be faster. It is very useful for P2P file sharing, content distribution. Actually, there are already some examples like BitTorrent, like Avalanche from Microsoft. It is clear it can provide higher throughput and easy scheduling and lower delay, instant messaging, network tomography, distributed storage, many possibilities, and also security that I forgot to mention. Now, of course, not only you have this, of course, is also coding. So then it additionally gives you the capability to face all the types of errors that you can find, like random errors, erasure errors, malicious nodes that inject malicious packets in the network, related to the security that we said before, and errors in headers. So there are already different approaches to take care of all these errors. Next. This is one of them, for example, which is very useful from a gradual deployment point of view, in which you separate the problems. One thing is the network coding problem that we saw before, that does not assume errors and just provides you the means to achieve capacity of the network, the maximum throughput that you can get, and is separated from the error correction problem. So then you can take care of the throughput achievability on one side, and then you say, okay, if in addition I have errors, I can also do this, this approach where you, again, abstract all the network as something, as a linear operator, right? So in this linear operator, now you have an addition factor which takes care of the error and how this error is transformed through the network. So this in particular is what is called an adversarial error model. And of course, I don't have time here at all to go into possible implementations, but you have to know that there are many solutions and constructions out there, and all these ones here, for example, have been produced in a European project, cost action project. This is the link. Please, next. Okay, so then we have now this tool here that is very well known in the network coding and coding area. So what am I doing here? What I'm doing here is that coding is, network coding is quite interdisciplinary, but it's even more because from all what I've said, we have now to bring it into networking. So for one side, we have the telecom engineers looking more in the physical aspects, the network computer scientists that are here, for example, the theoretical computer scientists, whether it is NP hard or not, and then the very coding theorists that provide us with the codes. So we really need to put all this together to make it work and to provide you with this tool that will help you to get much better performance of the network. Okay, so then it comes the virtualization, because as a first approach for the network coding, we say, okay, let's go through all the protocol stack, and then we, as I said before, we can implement the network coding at every layer as some protocol there, doing fundamentally coding. But from a network coding point of view, what we can is, and since I told you that the essence of the concept is this transition from thinking as a physical network flow to a non-physical network flow, what we can see is that from a network coding point of view, we can think of the physical information flow, a virtualization layer, and then with the information flow already abstracted, we can just do we can change our mindset and think in functions and computations instead of a layer-based protocol. So it's a change of thinking, of mindset. Yes? So now I present a possible way forward to do this. It's a follow-up of ideas of the network coding group, research group that is in IETF. They were first proposed there, but we saw that it's exactly what you are doing here. Then, as I said also about, it is a part of the output of this European project. There is already a paper covering these things. There are these things also proposed in white papers in this Network 2020 that supports 5G PPP initiative. And there is this H2020 project that is validating some of the ideas. Next. Yeah, so the basic idea is the following. First is an approach that combines the system-oriented way of design, which is closer to ITU ETSI, meaning system thinking, blocks thinking, and combined with network-oriented, IETF, which means flow-oriented. Why? Because we have functions. So functions relate blocks and the flow between the blocks. So that's why the approach combines both. And the basic idea is that the network coding has a functional architecture. So there are the coding functionalities that are taken care of by the coding theorists, the information flow engineering functionalities that are useful here in this working group, and then, of course, the physical virtualization functionalities that make the thing work. So this is the basic idea. Yeah.
Sorry, no.
It's okay. No. And so just graphically, what I'm saying is this. We will have, in our network architecture design framework, we have the domains, the design domains, where we take care of codes, powerful codes. So you have a pool of codes that can be used. And then we have a functional domain where we give you which functions you need to engineer networking. And for example, you can see that exactly this functional domain can be directly mapped to the architecture that you're using here for VNFs. So VNFs, so could be just one VNCF here, the virtual network coding function. Yeah, so then all these ideas have been validating in this H2020 GeoVision project, where we are developing what we call GeoNetwork coding for communications involved in United Nations operation, civil protection and law enforcement. So it can be really, and we are using also satellites, so it can be really a quite large scale network, also a small scale, but should be very dynamic and scalable. And so what the functionality that the network coding is providing to this project is geospatial control of reliability. So depending on the nodes we control the network flow so that the reliability, so the quality of the network of the flow is what we want, which doesn't mean needs to be the same for all the nodes. So in a spatial geospatial way, we control this. And we do so by the coding functionality I mentioned, in this case is a systematic network coding, which is that kind of efficient way. Then an optimization functionality where we reduce energy consumption and complexity at the nodes, because some nodes may not cope with the complexity, and we also have an analytical model for taking care of this, which could enable orchestration. Okay, so basically these are the main ideas. Network coding and coding for network coding are both coding concepts, as the title says, but my message here is that it's also a networking design tool that is useful for you. So you have already codes out there. It is applicable to real packet networks for the control and optimization of the network information flow across layers and across networks. And functional architecture, which is the way forward that is proposed here, it enables the design of virtual network coding functions. So finally, yes. Oh, no. So finally, one, two, three. The third point of the objectives was to get feedback from you. And so any question is very welcome, because any question will be already a lot of feedback. And this is from the Stargate that you can really visit here in Berlin. Thank you for your attention.
Stevens. Okay. We had time for two very fast questions. You two are there, so.
Okay, so Stephen Wright, AT&T. So thanks for an interesting presentation. If I understand your network coding, you are mixing multiple streams of traffic together. So,
You may or may not. This is part of what you can do.
Part of what you can do. I guess taking that perspective on this technology, I think it would be interesting to see this from the network service perspective rather than the VNF mapping. So I think of this as you're somehow creating a hierarchy of network services. And so that perspective on this would be helpful.
I agree. I would love to do that.
Yes, hi, Dan Bogdanovic. Did you compare it to a P4? Because P4 also allows me to do, layer independent functions and, that are also independent of hardware.
You can, no, I have not compared. You can compare with things. I agree this should be done. But what I try to say here is that this is like a different way to do things. It's a different.
As a note, P4 is about forwarding at the end. It's forwarding, and this should not be forwarding. It's complicated, but this is something that as a final, while I open your presentation, thanks, Angeles. No, what I would like to ask Angeles is that if you can write a very short draft, putting your ideas in a document, not in a presentation, so we can elaborate it a little bit and have comments like dance, etc. on the list would be ideal.
I will be very happy to do that.
Thank you. So, Rankin, you have 5 minutes to show 2 presentations. That's the price of being the chair, because we cannot be accused of eating at the time.
Policy-based platform awareness. We talked about it last time, so kind of a quick progress update. Even before that, a quick recap of what we presented last time. It's a flexible infrastructure policy model, declarative imperative. Of course, initial focus on OpenStack Nova, and all this work started, due to effort on policy-based resource management activities. And so the goal has been extend Intel EPA beyond compute, get network storage awareness, and also work with all orchestrators, open source and commercial. And we had our first successful presentation at the last OpenStack Austin Summit. And please take a look at the slides if you haven't. Go ahead, next slide, please. So progress update. So the key was, rather than we essentially got to the Nova community, well, the feedback was a policy is interesting, but even before that, there is another even more interesting critical problem to solve. This is around capacity modeling. In fact, that's exactly what Robert was alluding to. And we have started some real work there in terms of, talking about specific capabilities. Initially, we started with networking, and also then, that networking capabilities will be across NICs or vSwitches. But as we move forward, we plan to bring storage or, and also address other interesting subtle gaps around compute, like for example, L3 cache, all those. And all these, what we see is capabilities will be the most popular one, but also certain attributes will be more capacity oriented. For example, bandwidth or number of virtual functions. So predominantly capability, but some capacity. And essentially what this lays is a foundation for, essentially you can do a declarative or imperative policy on top of it. And our goal is to make sure that whatever we are proposing is completely backward compatible around the current capabilities which are proposed, which is just been following the imperative model. And we have a spec in OpenStack, and please take a look and please comment on that. And also notably, we talked about the kind of the inter-domain capability exchange model before in the context of 5G. So what we are thinking is, as we progress, all these work items are going to line up together. So essentially contribution in open source and then lining up to data models, information models, and other relevant projects.
So we're done with this.
If you have any quick question, go for one. Otherwise, we'll do it together with the next one. Excellent.
Now the other one, which is this one. Showing.
Again, I'll one slide. So
okay.
Excellent. So in this, so essentially, this is all about stirring up ideas and discussions. As Chaz, we felt security is a hot area, so we had some initial thoughts on implementing virtualized functions as functional classes. Now we said, hey, let's bring it to the group here, and then get some initial thoughts, feedbacks, and also stir up discussion. It's really motivational at this point. So next slide, please. So if you really look at what are the partitions on a standard VNF implementation, if you look at it, hey, there is a forwarding class which is router, right? And sorry, forwarding class is just routing functionality, but processing class, something like a TCP proxy, then a network control class, essentially routing protocol, BGP or anything else, and then management and orchestration class. An example is OpenStack controller, then OAM class, example could be performance monitoring tools. This is kind of the functional class partitioning we're thinking. And next slide, please. So why is all this relevant? So consider some use cases. As technology is evolving, we're talking 5G networks, network slices, right? So these are the functional class we see somewhat relevant, and now is 5G going to add another dimension of complexity? Is it really multiplicative? Each slice into so many classes. Is that what the right approach is? And again, containers and versus VMs. Cannot assume only VMs. It also could be containers. Then security needs to be rethought. So these are some of the additional considerations. So next slide, please. So just again, what does all this mean? Class separation. So if you look at something like an isolation breach, example, a data overflow, right? It can have a serious side effect in the management class, as an example. And also what we see is potentially different types of DOS attacks in each of the class, right? I mean, specifically in the management class, just 1 or 2 packets may, bring a huge havoc, versus how things happen in a data plane in an other class could be different, right? And also when you look at service verification, we see different types of requirements, across different classes. And again, this could be periodic or event driven. Next slide, please. So more on isolation breaches. So specifically, specific examples: data overflow, packet address to a processing function, could override memory space of a control function, or OAM. If it's a OAM performance monitoring, it could override the address space of a processing function. These are some of the potential examples, and there could be more. And again, data leakage is an interesting topic. In the interest of time, we'll skip. So go ahead, please. So next steps. So the key question we would like to ask is, hey, is there interest in this effort? And then, love to hear your thoughts. And we also see something like 3GPP work also somewhat proceeding this direction, though not exhaustive, like 3GPP CUPS, specifically CUPS initiative. So yeah, maybe a couple of questions, maybe just a question, and then rest on the list, I think.
Is 3GPP doing something about this?
So I think there's a 3GPP CUPS initiative. So, but not so exhaustive, but kind of, I think some initial work is going on, but not to the level of, but again, that's more mobile centric. Our goal is not necessarily limited to mobile, but also say if you consider CPE use case, right? Yeah, business CPE on enterprise premise, all of this is applicable, but not fully thought through.
Stephen Wright, AT&T. So, so by classes here, I understand you're talking about a classification scheme as opposed to inheritance type software design things. So a particular VNF could belong to multiple classes. If it's a complex VNF, if you take an existing network function and just put it in a virtual machine, it's probably going to have multiple, probably fits in multiple classes. So what's really the purpose or the uses of the classification scheme, and how do you know that you've got enough classes? So it sounds as though you're trying to identify classes so that you can develop some tests around if they're straying out of their designated functionality, but I'm not sure how well that's going to work if you've got really complicated functions that belong to multiple classes.
So I think, I think specific examples are like, say, if you take a CPU use case by class partitioning, what you're trying to say is that, hey, how you kind of manage your resources and kind of specifically any security paradigms you construct are different for different classes. And you can, that way you're delivering full security in the solution. Whereas if you have not thought through those aspects, what happens is you drop in, say, a third-party monitoring application, and then because your paradigm is not set right, then that could cause a havoc on the management class. That's kind of the ideas we're thinking again, something like that.
It may be better to take a different approach to the classes. If you think about the problem of migrating existing network functions and cloudifying them, right? Depending upon the model that you do, there's 3, 4, 5 stages you go through before something's cloud ready or cloud native. So having classes around that is probably, as to how cloud mature the DNF is probably a helpful classification scheme in terms of implementation maturity that would be, I think, of interest to folks. You might be more interested in knowing whether something's much more cloud mature than not, for example.
It's a good suggestion, Steve. Thanks.
Okay.
No, comments are the list are welcome, I think.
You told me that you were able to make a demo in 10 minutes. You had 10 minutes, Robert. Well, 10 minutes. Actually, you have 5, but I guess that the people here would be happy to stay at least for additional 5 minutes. You want to see tomorrow?
If I can.
Well, here you go.
Thank you. So I'm back, and actually I would like to present drafts, updates related to 2 drafts, the recursive programming and SFC control plane experiment, and also to run a demo live. My colleague Balázs Sonkoly from Budapest University of Technology and Economics will assist me, and he's also the co-author of the SFC draft. Just a reminder on the recursive programming. So we proposed an abstraction which transfers from different cloud and network control into a joint cloud and network control API and abstraction. And by this means, we can, in one atomic operation, define basically VNF placement and interconnection or service function chaining related to these VNFs. So that's the point of the recursive programming draft, the proper abstraction and the programmatic API. What this can be used of, for this, we can create, basically build domains technology agnostically in a way that we recursively create a resource orchestration hierarchy. And for each of the nodes-bound interface, we can create a domain abstraction based on this big switch with big software model. This can be an arbitrary topology of such big switch with block software components. Okay, what are related to this big switch with big software components? To the upward direction, they are reporting basic resources and supported VNFs. So this relates to the capabilities discussions. So for each of the VNF type that is supported, we report CPU, memory, storage, and their associated delay and bandwidth or latency and rate characteristic per VNF ports. So for each of the VNF ports, we can describe such characteristics. And for the request, we request a VNF type, and we define either CPU, memory, storage, which equivalent to basically a flavor, or we define the bandwidth and the delay requirement between two VNF ports and leave it to the resource orchestrator to pick the appropriate flavor for that. So that's about the domain abstraction and the recurring domain programming. In the SFC control plane experiment draft, we showed how to combine this big switch with big software approach into realizing network function, virtualization, and forwarding into to create a slice, basically, which defines service function chain. So we transited the whole idea into the service function chain control plane, and we step-by-step shown how, starting from the SFC control plane, we can arrive to the right-hand side picture, where such SFC control plane could be grouped together by all the functionality that we try to put into this resource orchestration and the appropriate abstraction there. Okay, that's about the drafts. So what about the use case? So we have two robots there. These are Lego Mindstorm robots, and the original setup is that the PID controller runs within the robot, and this is invoked every 20 milliseconds in order to keep the robot in vertical state, so self-balancing. But then, just to have some imaginary industry-like scenario, we try to move the balancer logic, the controller, into the cloud. So this puts very stringent requirement on the cloud performance, because we cannot place anywhere the speed controller. This should be placed close enough to the robot in order to meet this 20 millisecond requirement. Actually, the robot can stand upright up to 30, 35, or sometimes even 40 milliseconds, but we are very, very sensitive to the Wi-Fi glitches. And then, just to extend the use case, we will introduce an additional network function in the splitter in order to achieve fault tolerance. So, for example, one of the cloud component is out, then we would like the robot still balancing. As a reminder, on the left-hand side of the figure, all these are realized as a service function chain by jointly instantiating the VNFs and connecting them in arbitrary pattern. And to further enrich, we will add extra functionality. So based on the additional sensors available on the robot, we will introduce additional service functions, like receiving a color sensor or receiving a proximity sensor. We will influence the PID controllers. And we will attach these additional functions in the fault-tolerant architecture. So for example, if you have multiple PID controllers, then we will feed both of the PID controllers with this extra control logic. Okay, so what do we have here? Basically, the idea is to transfer from software definition to service function chaining as realized in the physical distributed system. So what we expect is that in the future, people will write software components independent of the physical architecture. So there's a robot, and on the robot we run sensors and actuators, and there's, in this example, a self-balancing PID controller software component. And these are basically the software design that we would like to map to the physical distributed system. So we provide the VNF type and the requirement, and then the resource orchestrator will put this into the physical distributed system in order to realize as a service function chain one slice for the robot. Then, if we add an additional robot for the same physical access point as we will show, then we will create an additional slice. So this will go into two distinct slices, but the running components will be exactly the same thing. So we just have one image, which is exactly the same, one clone of that image, and that will be instantiated as many times as many slices we would like to support. So at the end of the day, we will have the same software architecture, same software design, and by the request for different slice realization, we will deploy as many such components, as many slices we define, and then feed the corresponding traffic into a proper slice. And then these will define at the bottommost layer slicing. Okay, so the network scenario that you see over there in the table. So we have a Wi-Fi access point, and the robots are communicating by Wi-Fi. We are very sensible to the Wi-Fi glitches, as I said. We have basically three SDN domains, two hardware SDN switches, and the transit network and access network emulated in Mininet with soft switches. And then this represents basically an edge pop, edge computing, where we can place in a Docker environment the edge pop containers, which are close to the access point. And in the remote Docker environment, we can place something like into the central cloud containers. So this is the basic network scenario, and then we will try to run a demo live. So the first setup will be one robot attached to the access point and a splitter in order to go for multiple balancing servers in the next step, started by Balázs. Okay, let's see. Here on this tool, you can see how many containers are running in the different Docker environments. And on the bottom part, we will see round-trip time measurements from the robot. So actually, what we should see is that in the edge pop, we started containers in order to have the robot balancing. And on the right-hand side, you should see round-trip time measurements reported by the robot. There should be only one measurement reported by the robot because we only deployed one balancer. And due to the Wi-Fi glitches, we are using some algorithm within the robot so that if there's a 100 millisecond glitch, it can still maintain its balance for up to 1 second. So that's why you may see 2 round-trip time measurements. So let's go to the next setup where we will, on the fly, seamlessly extend this setup with an additional balancer connected to the splitter. And then we will hopefully achieve fault tolerance in a way that any of the data plane components, any of the cloud, if any of the cloud is disconnected from the physical system, then the robot should still be balancing. So Balázs disconnects one of the cloud. Okay, the robot still stands. Can you disconnect the other one? It should fail. Okay, so this is the basic setup by the means of network programming.
So that is John plug things this over.
Yes, yes. But we can achieve basically using the same component. We can achieve a kind of fault tolerant in the cloud with no additional design in the software environment. The robot is very sensible. We have to keep it because it calibrates the gyroscope when starting. Okay. So additionally, what you can see here, there's a white sheet of paper, and on top of which Balázs starts the robot. So this is not considered with this first setup because we don't have the color sensors instantiated into the system. But if we will send the next setup, which will include the color sensor and the proximity sensor into the service function chain, then we should achieve that the robot stays within this white border because of the color sensor, and Balázs can basically influence the robot by going closer to the proximity sensor. You see, in the previous setup, this functionality was not included in the system, but by mere changing the service function chaining, we can add additional functionality into the setup. And then, as a last thing, if we go for an additional slice, where for the same access point, we will start another robot and deploy one more balancer, and then this PID logic will be mapped again to the cloud. It will come back because now the box spot. Yes. So you can see here that how many balancers are running, and actually sometimes you see the glitches. So Wi-Fi is not so reliable. We try to optimize a little bit the Wi-Fi and dropping packets for the price of better round-trip time, but still occasionally we have something like over 100 millisecond glitches in the Wi-Fi. Okay, let's see if we can see both of the robots standing. Okay, so now we have 2 slices automatically orchestrated. They are using, most of the slices are using exactly the same components. So in the Docker environment, they're just one image, and that image is started for one of the robot and the other robot, and one of the Docker environment runs actually both of these. Okay, a few words about the orchestrator. So the resource orchestrator takes into account basically a service graph, that is this high-level definition of the service component and requirements on edges, delays, CPU, and other parameters. And based on that, it automatically maps the request to the underlying physical infrastructure as best as it could. So this is autonomous, and everything is hidden from the developer. One more thing is that the resource orchestrator tries to do this in a technology agnostic way. So in this very small setup that we brought here, we only have this Docker environment and SDN switches. But on Thursday, we will run a large-scale demonstration at the bits and bytes session. We will have OpenStack domain. We will have a unified specific universal node with data plane optimization. And all these service functions are mapped transparently to the underlying physical infrastructure, whether it will go into OpenStack, a containerized environment, or some hardware-accelerated universal node. Okay, just a few things about this bits and bytes. So the bits and bytes demo will not only show this recurring programming and flexible service chaining, but it will show the elastic control API that we are proposing within this resource orchestration framework. And we will have an elastic router demonstrated there with high performance. So we will go up to 40 gigs, hopefully, on the data plane without influencing other slices. And there will be DevOps toolkits also demonstrated in this setup environment, for example, dynamic aggregation from SDN passive monitoring. And this is the bits and bytes scenario. So as you can see, this is much more complex. We will have many slices and much more heterogeneity in the physical environment. So you are kindly invited to visit us at the bits and bytes session. And in a summary, so we have a couple of drafts related to this domain abstraction and recurring domain virtualization and control. We also included in these definitions how resources and capabilities could be reported. We showed with the draft how to transform from this SDN Nfvrg word into the service function chain control plane, which we would like to bring into the discussions, and we have also identified as a missing piece in the policy-based resource management draft. Implementation-wise, we have this multi-technology and multi-domain support, and as was mentioned by Luis in the presentation, now we are investigating how to extend this into a multi-provider environment. We demonstrate here network slicing concept, and the whole process from the top, from the software component to the actual service function chain realization is automated. So we define software components, then we translate it into service function chaining, which are deployed as network slices. And most of these components are available open source, as indicated in the link. Thank you.
So Robert, since you talked about slicing, hidden message 5G. Just kidding.
Yes.
Okay, no, everything. No, this in particular is not 5G yet, right? Well, okay, just with this, let me conclude with one thing from the, I mean, many of you, there are many questions that you want to make. I would suggest that you go to the Bits and Bytes booth. And so let me conclude with one thing. Thanks, Robert, because this is a proof that it works, and this is important. See you, or most of you, in Seoul.
Yes. We believe in running code, right?
Yeah.
How are you?
The other blue sheet. Oh.
Yeah.